All right, so today's 6.2 and 6.4. We're talking about factoring trinomials of the form x squared plus bx plus c, and they're also going to be factoring polynomials where we have a value of a that is greater than 1. The first thing, factoring trinomials with a leading coefficient of 1, as mentioned. Is it white again? It's white again. Right. Okay, we look here at the example. We have x plus 3 times the quantity of x plus 7. All right, so if we were to FOIL it out, we would get x squared plus 7x plus 3x plus 21, again if we FOILed it. And then once we combine the like terms of 7 and 3, we would have the x squared plus 10x plus 21. Right? So what we're wanting to do now is go from the factored out form into a factored form. Okay, so we've all done two binomials and FOILed and got the trinomial. We're going the opposite way now. Right. So first thing, let's do an example. All right, so here's how I do it, and this is how I'll also do it for the next section when we talk about the AC method. Okay, so what I'm going to do here is, and you know what, as a matter of fact, I'm going to go ahead and do AC method essentially, and you understand what I mean by AC method. Let's see, do we have the definition of it? Not quite, but no, let's not get confusing. All right, so what I'm going to do is I'm going to look at this C value here. Okay, it's C because A would be essentially the first number here, which is a 1. B would be the second number, and C would be the third number. When I say number, I'm talking about the integers, not the variables. AX squared plus BX plus C. That's what I mean by AC. We have the A as a leading coefficient and C as the constant in the back. So what I'm going to do is I'm going to look at the number negative 45, okay? But for this purpose, I'm going to look at the number 45. Okay? I'm going to do it's a tad different from the textbook. All right, so what are my factors of 45? So I'm going to just go down the list. I'm going to start at 1. Well, it's easy. 1 times 45. Okay. 2 doesn't work, but 3, we got 3 times 15. 4 doesn't work. 5 does. We got 5 times 9. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. Wait, 9 does. Okay, 9 does work, but 9 is just 9 times 5. Okay, so we can stop there. Now I'm going to ask myself and ourselves, I guess, 2 questions. The first question would be, all right, so when I multiply these two numbers, these factors, all right, I need to satisfy 2 criteria. Number 1, when I multiply them together, I get a negative 45. Okay, and then when I add them together, I get a positive 4. Okay, and everybody's familiar with this setup right here. Okay, so it's an x squared, so I can also put x here first off. All right, well, when I multiply them together to get a negative 45, obviously one needs to be positive and one needs to be negative, right? Because obviously a negative times a negative would be a positive. All right, next thing we have to do again was have that positive 4 there. All right, well, when I add or subtract these two together, what will give me a positive 4? Okay, well, there's no universe where I can add or subtract 45 and 1 together to give me a positive 4, right? If it's 45 minus 1, that's 44. 1 minus 45, that's negative 44, so on and so forth. There's no universe where I can get a positive 4 out of adding or subtracting them together. And obviously the only answer would be this. right? 9 times 5 will give me a positive 4. Perfect, right? So I need to have a positive 9 and a negative, did I say 4? I meant 5. Positive 9 and a negative 5, right? I know that a positive 9 and a negative 5 is a positive 4. I also know that a positive 9 times a negative 5 is a negative 45, right? And we're done, but for the sake of this, let's go ahead and FOIL it and see what happens, okay? So first thing I'm going to do is x times x, so that's x squared. I'm going to have x times a negative 5, so it's going to be negative 5x plus 9x minus 45. We're going to combine the like terms, so we're going to have x squared. The negative 5 and the plus 9 gives me a plus 4x minus 45. Okay, and that is exactly what we have. Now, I went painfully slow through that, so if you were a little bored, trust me, I do speed it up a little bit, but for the sake of getting our feet wet on factoring trinomials, I do tend to go a little slow at first, and the AC method in 6.4 will really kick it up. Okay, so same thing. What we're going to do is we're going to look at the 50 here. We're going to ask ourselves, all right, so what are my factors of 50? Right, and I do encourage you always to honestly do it the way I do it. I just write the number, and then I start at 1. 1 times 50. 2 times 25. 3 doesn't work. 4 doesn't work. 5 times 10. 6 doesn't work. 7 doesn't work. 8 doesn't work. And then, of course, I guess we're done there, right? Okay, so I'm going to look at these factors again, and I'm going to ask myself, okay, so of these three factors, which factor, when I add and subtract together, will give me a negative 15? Okay, and again, same thing with the previous slide. 1 and 50 will never give me a negative 15. 2 and 25 will never give me negative 15 rather. But 5 and 10 will, won't it? A negative 5 and a negative 10, they will both give me, or they will put, adding them together, and a negative 5, and x minus 10. Stay consistent here. Okay, so when I multiply these two together, they do give me a positive 50, and when I add them together, they give me a negative 15. So let's just FOIL again to really drive this point home. X squared minus 10x minus 5x, and again, it's a negative times a negative, so it's going to be plus 50. Combine the like terms, and we indeed have the exact same as the original problem. All right, so sine rules, let's not get into that. I don't want to get overly confusing here. I mean, yes, you could read it and keep, you know what, let's actually put that there, just in case you do want to look at this and kind of go over it. But to me, I feel like the more rules you have, that lends yourself to getting a little bit confused a lot more. At least it was for me, right? Okay, so example 3, let's see. All right, well, this is actually pretty short. No wonder we're doing 2 sections today. All right, so we'll go ahead and do this. I was going to skip something if not, because I know we've got the big section for today, the one that's going to be a little bit harder. This is obviously a little bit longer. Okay, so example 3, we just have to factor, okay? Now, you're going to have a lot of problems like this, and you're familiar with putting things in descending order, correct? So that's what we're going to do here. We're going to put these in descending order. So we're going to start first with excuse me, I'm going to start with A. And I'm just going to rewrite it again in descending order, so it's going to be p squared minus 8p minus 48. All right, so there's nothing different here. We can just do the. Now we're gonna do this. We're not gonna do this in our head. Okay, so we're gonna let's split this page into two, so we can keep things on task. So we'll do A on the left side and B on the right side. All right, so what I'm going to do is I'm going to come up here again, and I'm going to say, okay, I'm looking at C, my C value. $48. All right, it is indeed a negative 48. However, let's see. Before I continue, let me show you why I just do the positive component of it. I'm pretty sure example 1 would be a really good example here. Okay, so if you recall in example 1, all I did was say, okay, so I'm looking at 45. I just took the positive component of it, meaning I just said positive 45, right? I didn't say negative 45. The reason being is because, so similar to the table that I make here, if we were to proceed with it being negative, and again, there's nothing wrong with proceeding with the assumption that's a negative 45 because it is a negative 45. You have to do negative 1 times positive 45, and then you also got to do negative 45 times 1. All right, you have the negative 3 times 15, and then you've also got the negative 15 times 3. And to me, that just becomes very cumbersome. There's no need to write all that stuff, right? So I just go straight with the positive component of it, and then move on to, okay, so which factors, when I add or subtract them together, will give me that value of B. Okay, so 48. One of my factors is 48. Again, we start easy peasy. We go with 1 times 48, 2 times 24. I believe 3 gives me what? 10, 16? 4 times 12. We got a lot of factors here. 5 done 6. I believe 6 times 8. 7, and we're done. Okay, so we've got a lot of factors here. Okay. I don't like the way 16 kind of looks. We're going to have to deal with it. Okay, so when I add or subtract these together, which ones will give me a negative 8 rather? Okay, well again, looking at all of them, only one of them will give me a negative 8, and that is a positive 12 and a negative 4. So therefore I can write this P, and that's at a positive 12 and a negative 4. Okay. Now, sorry, negative 12. I know many of you are thinking it. Okay. Now, I have been asked, and normally in a classroom when it's a lot easier to ask questions, I will have a student ask me, what if I did this? Okay. Well, it's okay. It's the same thing, right? Multiplication is commutative, meaning we can swap them. No big deal, right? 3 times 4 is 12. 4 times 3 is 12. So it doesn't matter which goes first necessarily and which goes second whenever we do this. Okay. All right. Next up, we're going to go ahead and put it in descending order again. So we've got we'll just denote that this is B. We've got a positive 10t cubed minus 30t squared minus 40t. Something I also encourage you to do is write your t's kind of like mine, right? Obviously you don't have to, but it really helps, especially when you have something like 3t plus, 9, right? Sometimes people just write 3t plus 9, and it looks kind of ridiculous like that, doesn't it? So put a little serif on your t if you want to. Makes things look a lot nicer, in my opinion. Anyways, looking at this problem, 10t cubed minus 30t squared minus 40t. All right, well, we don't really have any tools right now to factor a third degree polynomial, but luckily we can essentially break this down into a just simply a second degree polynomial, right? First thing I do is I look at all three terms and I say, okay, so I can pull out a t there, right? Of course I can, but that's not all. Okay, I can factor out a 10. Right, that leaves me with t squared minus 3t minus 4. Okay, and then it just becomes pretty easy. We're going to ask ourselves, okay, so what are my factors of 4 that'll give me negative 3? Well, that's pretty easy, right? So we're going to make sure you keep this 10t out front. And then we got a t here, t there, and what negative 4 or positive 1. And there's a good example right there. The little serif on the t helps a little bit, right? It's not going to be much of a difference. So you can do what you want to, but I would just suggest it. 10t times the quantity of t minus 4 times t plus 1. So that 3, that was 3. Let's see, 4. Number 4 is much the same. 5. Okay, we'll jump to 5. Actually, let me make sure example 4 isn't anything tricky here. Let's go ahead and do it. I like the idea behind it. Maybe what I should do for problems that have multiples, put this in the middle and split it that way. Okay, so let's look at A. I believe it was this class. I mentioned last week that it's typically easier to we make sure the first term essentially in the quadratic equation is a positive because it's easier to factor that way. All right, so I'm going to go ahead and write this in factored form. I'm going to factor out a negative 1, and that leaves me with a squared plus, so a squared minus 6a plus 8. Okay, so all the tools that we've done leading up to now make factoring this equation a lot easier than factoring this. They're the exact same, essentially, right? One of them being that I factored out a negative 1 there. They're the exact same, but it makes it a lot easier, and we'll see exactly why when we get to the AC method in the next section. But that's why last week I said that we typically want to have the number in front of the a squared be a positive 1. All right, and then we can proceed here. Make sure you always bring your factored negative 1 down. All right, so we got a here. What are my factors of 8? When I add or subtract them together, it will give me a negative 6, so that's pretty easy. We've got a negative 4 and a negative 2, right? Negative 4 times negative 2 is a positive 8. Negative 4 minus 2 is a negative 6. B. All right, so this is actually I'm glad we did this. This is pretty interesting. We've got a negative 2c squared minus 22cd minus 60d squared. Now, my first inclination right off the bat was, all right, we're going to have to put this in descending order. That's because I was looking at the d squared first instead of c squared. Okay, so it doesn't really matter what we do. Obviously, many times it's just kind of alphabetical order, right? X, Y, Z, A, B, C. So we're going to do the same thing. We're going to factor out a negative 1. And what remains, we have a 2c squared plus 22cd. I'm going to write it a little bit underneath it. Again, the recording, whenever I put this on YouTube, it cuts off right here at that gray line. So I want to keep that a part of it. So -1, we get a 2, well, that sun just came out, didn't it? 2c squared plus 22cd plus 6d squared. All right, now honestly, I probably should have factored out a -2. So we've got the -1 factored out, and we're looking at this problem. We have a 2c squared plus 22cd plus 60d squared. And then I said, okay, we probably should have factored out a -2 instead of a -1. All right, but let's just proceed with this because many times, just like I did just now, we do kind of operate on autopilot, right? Autopilot being whatever the last thing we learned. And the last thing in this particular case that we learned was factoring out -1. But I now see I can factor out a 2, so what I'm going to do is I'm going to pull a 2 out. All right, I'm going to pull out a +2 out of all of these. And then when we do that, what's +2 times a -1? What's a -2? So it still ends up being the same thing if I were to pull out a -2. Okay, so c squared plus 11cd plus 30d squared. Okay, now this does look kind of ridiculous, but let's rewrite this. I say kind of ridiculous because we have the two variables involved here. Right, normally we've been dealing with just one variable, in x or an a and a rather. And this time, what we're going to do, we're going to kind of set up the exact same. Okay, we're going to put a c here and a c here. Okay, but since we have a d as well, the d squared down here, I'm also going to put a d here. Those are awful looking d's. I'm really sorry. That didn't look any better. We're going to stick with it. Okay, so since we have the c squared in the front and the d squared in the back, we're just going to go ahead and put c's and d's here as well. Okay, next thing we're going to do is just kind of follow the exact same rules that we did before. Okay, so what are my factors of 30 that when I add or subtract them together will give me an 11? Okay, well that's easy. That's going to be a 5 and a 6. So we're going to say plus 6d plus 5d, and we'll be done. Okay, so if we FOIL this out, you'll see that, and let's go ahead and FOIL it out just to really see what it looks like. Okay, so we've got the c squared and then plus 5cd plus 6cd plus 30d squared, and went over the gray line. Oh well. And of course we can see that if we combine our like terms here, we have an 11cd. Okay. All right, last example for this section. And honestly, I'm just going to snip this whole thing because there's not much I can add to it, really. Okay, similar to how if we have a number that we cannot factor, like number 13, right? The only factors of 13 are 1 in itself. We call it prime. Same thing here. If we were to look at this particular problem, we'd look at the number 14 and we'd say, okay, so what are my, oh, this is actually pretty good. I would say, what are my factors of 14 that when I add or subtract them together will give me a -13? Okay, now of course you'd be thinking, well, a +14 and a -1, right? And you would be correct, except, let's go ahead and write this. When we said a +14 and a -1. Okay, you might be quick on the trigger to do this, And you're not wrong if you said the positive 14 and negative 1, because that is indeed a negative. Should put a negative sign there. Negative 14, positive 1. All right, that would give me a negative 13, but what about when we did the last part of the FOIL? This would be negative 14, right? And let's just go ahead and actually do all that out. If we FOIL this, we'd have x squared minus x plus x minus 14x and then minus 14. We combine the like terms. We have x squared minus 13x. Looking good so far, but then we've got a minus 14, and that's where we differ. Okay, looking up at here is a positive 14. So and of course, no other factor of 14 will work to give me a 13. So what we would say is we have this trinomial, and we cannot factor it. We cannot put it into two binomials. So therefore, we would call it prime. You will have plenty of those. They're kind of tricky. They give you they like to waste your time here. All right, that was 6.2. Let's jump to 6.4. And now we're going to get to the AC method. So let's real quick just see how many examples we got here. No, it's just 6. It's not too bad. The concept is a little bit trickier though. All right, so it reads, we've already learned how to factor a trinomial to form ax squared plus bx plus c equals 0 with a leading coefficient of 1. As I mentioned before, that being a 1 right there for the a. Then we learned the trial and error method. Oh, I know what it is. Okay, so I actually skipped 6.3. 6.3 is the trial and error method, and I'm not a fan of trial and error because I like strict procedure. I don't want to go through a particular problem and just kind of guess. So that's what that's reading is trial and error method. Even though it says we learned it, but we didn't. In this section, we provide an alternative method to factor trinomials called the AC method. All right. So let's see if I can say this better than this book. Not entirely. I think it might just be easier. Actually, we'll snip this sandy box right here. Add it to current page, and I'll just keep that. I'll put this here for anyone that wants to look at the notes. But I'm not sure if I'm going to follow that verbatim. Okay, we call it the AC method because, again, let's go ahead and write this as ax squared plus bx plus c. All right, and if I were to write the actual problem beneath this, 2x squared plus 7x plus 6. Okay, we're able to tell really quickly that a is equal to 2, b is equal to positive 7, and c is equal to 6. Okay, so we call it the AC method because we're going to look strictly at a and c first off. So let's do. What if I can move this over? Oh, not just the letter A. Let's move the whole thing. There we go. And let's actually put a little color into this. So let's write the problem back over here. Okay, so 2x squared plus 7x plus 6. AC method time. What I'm going to do now is kind of the exact same thing we did in the previous section, except instead of just looking at the C, what I'm going to do is I'm going to look at A times C. So let's go back and look what we've done before. Previous pages. All right, so this is one where I actually wrote it down. So what I did was I looked at 48. Oh, we're still in line mode. I looked at 48, and then I did factors of 48. And I can do that, okay? But I'm technically, I guess, multiplying by 1, right? 1 times 48, correct? Well, that 1 would be coming from where the A is. A times C, which is, 1 times whatever C is, because anything times itself is itself. So we're going to use that exact same kind of logic for the AC method. So here we go. My A value and my C value. What I'm going to do is I'm just going to write 2. Actually, let's do A times C, which is going to be equal to 2 times 6, which is going to be equal to 12. And I'm going to put that out a little bit further so I have room. A times C, which is equal to 2 times 6, which is equal to 12. Okay. Again, I do encourage you to go about the same way I do. That way we can very easily do our AC method here. Okay. All right, so I did A times C. A times C is 2 times 6, and 2 times 6 is 12. So what I'm going to do is I'm going to do my factors of 12, which are 1 times 12, 2 times 6, 3 times 4. Okay, now it's easier for me, and again, I'm going to go all the way back again to the last time I did a factor. It's easier for me to factor these because, I mean, I have been doing this a long time, right? But for many of you, you're fresh into college. You probably haven't done math in a couple years, or at least serious math. And what I always do is I always start at 1, 2, 3, 4, 5, 6, and I always just go down, okay? Instead of just randomly going, okay, 48. I know 48 is 12 times 4, and then writing that down and then having to come back. I just go straight, I start from 1, and I just go as far as I can until I repeat myself. Anyways, we've got, here's my factors. Okay, so looking at my factors, I would say, okay, so of these factors of 12, 1, 12, 2, 6, 3, 4, which factor, when I add or subtract them together, will give me this 7 here? Okay, well, obviously, a positive 3 and a positive 4. So, remember the factor by grouping we did last week? Hopefully, you got good practice on it, because we're going to be doing it a lot. So we're going to put a plus 3x plus 4x plus 6. Okay, well, what do I do? All right, well, do you agree that this equation is the same as this equation? All right, they both have the 2x squared. They both have the plus 6. The only difference being one has a plus 7x and the other one has a plus 3x plus 4x, which is equal to 7x. Okay, so they are the exact same. It's just that I rewrote it a little bit different. And the reason why is because of the AC method. What we're going to do here is exactly what we did last week when we did factor by grouping. So same as last week. What I'm going to do is I'm going to split this down the middle. Right? And I will say this. On your homework, it is random for all of you guys, and depending on where you're at in your knowledge and how well versed you are in mathematics. But some of you may have had some factor by grouping where you had to actually rearrange your problems. Okay, now that does get tedious, but I got good news. Whenever you do the AC method, you never have to rearrange your equation. You can just go right down the middle. and factor left side and right side. So my left side here would be, if I factor out, I factor on x, what remains? I've got a 2x plus 3. The right side, well, what can I factor out? I can factor a plus 2, a positive 2 rather. What remains? 2x plus 3. All right, and similar to what we wanted when we did factor by grouping, I got the same thing inside my parentheses. Perfect. So what I'm going to do, and let's go ahead and erase this a little bit, because I will have a 2x plus 3, and what remains? X plus 2. And we're done. Okay. Now, some of you might ask, some of you might be thinking, okay, well, you put the 3 first and then the 4 second. Well, what happens if you put the 4 first and 3 second? So let's do that. See if I can snip that. And let's rewrite it. Next page. So 2, 4, 3. Okay. So we have a 2x squared plus 4x plus 3x, and I think it was plus 6. Yeah. Okay. So the first thing I did on this page, I put the 3 first and the 4 second. All right. So you might just think the other way, right? You might want to put the 4 first and 3 second. Well, here's what happens. We're going to split it down the middle again. Okay. What do I factor out of the left side? Well, I factor out looks like a 2x. What remains? X plus 2. We're going to factor out of the right side. Well, it looks like a positive 3. What remains? X plus 2. So therefore I've got x plus 2 and 2x plus 3, which happens to be the same thing. Okay, so it doesn't matter what number you put first, the 3 or the 4, you'll always get the right answer, or the same answer, which would be the right answer, wouldn't it? Anyways, that is the AC method. So another example. I put this over to the left. Once again, we're going to need to write this in descending order. So we're going to write this as 8x squared minus 2x minus 3. Okay. And I'm going to give you a moment to do this on your own, and I'll be back in a second. All right, I'm back. Yeah. Might have been a little quick, so I'll give you a few more seconds. Alrighty, so we're going to look at the A value and C value. Okay, so again, the textbook would say 8 times negative 3, but again, I'm just going to deal with the positive form of it, and then kind of mentally deal with the negative aspect. Okay, so same as the previous slide, we're going to do a times c, which is equal to 8 times 3, which is equal to 24. Okay, again, not technically correct because it's a negative 3, but since I don't want to deal with the positive and negatives of all of them every time, I just simply write the positive of it. And I'll show you what I mean by that after we do this problem. Start at 1. 1 times 24. 2 times 12. 3, 8, 6, 24, times 8. 4 times 6. And we repeat it. We repeat ourselves. We do 6 times 4. Okay. All right, so again, I'm going to say, okay, so what are my factors of 24 that when they're added or subtracted together will give me a negative 2? Well, that's easy. It's a negative 6 and a positive 4. Okay, so it'd be this one. So let's rewrite the problem. 8x squared. And again, it doesn't matter what goes first, what goes second. But I'm going to put a minus 6x and a positive 4x and then minus 3. And then I'm going to do factor by grouping. What can I factor out of the right side? Well, it looks like a 2x, and that leaves me with 4x minus 3. All right, well, the right side is 4x minus 3, isn't it? So what am I going to do? Well, I can factor out a positive 1, can't I? And that leaves me with 4x minus 3. Excuse me. And then therefore my answer would be 4x minus 3, 2x plus 1. And that's it. Oh yeah, and I was gonna show you why I just do the positive component again. I mean, I did it in the last section, but I'll do it again for this section. All right, so let's draw your attention up here. All right, I did 24. I did positive 24, and I just did 1 times 24, 2 times 12, so on and so forth. The textbook, for example, does indeed do the negative 24. Okay, but this first column here proceeds as if the first number, or the negative 1, negative 2, negative 3, negative 4 are negative, right? And it is true. Negative 1 times, let's see, that's not what I wanted. Laser. Negative 1 times 24 is indeed negative 24. Negative 2 times 12 is indeed negative 24, so on and so forth. And then we have the other side. Negative 24 times a positive 1 is negative 24. Negative 12 times 2 is negative 24. But that's 8 different factors. And again, I want to write the least amount as possible. So that's why I just do the positive component of it, and then just kind of in my head okay, so when I add or subtract them together, what gives me the positive or negative value of b? So you can do either way you want, but I proceed this way. Ugh, this looks disgusting. Okay. Sorry about that. Okay, so descending order, it looks like it's already in descending order, right? So we've got the 10x cubed out front. What can we factor out? Well, first thing looks like we can factor out is an x, so that's pretty good. But it looks like we can also factor out a 5. So we can factor out a 5x. And what does it leave me with? It leaves me with a 2x squared minus 17x and then plus 21. Okay. So similar to one of the last examples we did on section 6.2 is we're just going to look strictly at, obviously, the polynomial. The 5x will get drug along. All right, so I'm going to just go ahead and put a 5x on here to show that I'm going to go ahead and drag it along. All right, AC again. So we've got the 2 and the 21. So A times C, which is 2 times 21, which is 42. One times 42, 2 times 21, 3, 13, 14. 5, 6 times 7, and then 7 is just times 6. Okay, so now I'm going to ask myself, okay, so of these 4 factors here, which factors, when I add or subtract them together, will give me a negative 17? Okay, well, that would be a negative 3 and a negative 14. So we're going to proceed this way. We're going to say 2x squared, and then minus 14x minus 3x plus 21. Factor by grouping. Okay. And again, before I do this, I'm going to bring my 5x down. I know many times I'll have students always forget that and will not put that part of the answer and get frustrated because the application says you were incorrect, because you are. Okay, so what can I factor out of the left side? Well, it looks like I can factor out a, let's actually put a bracket. All right, looks like I can factor out a 2x, and that leaves me with x minus 7. The right side, it looks like I can factor out, and this is important. If I were to factor out, just go ahead and factor out a positive 3. Okay, let's actually put this in red, just kind of point out I'm not doing this right. If I factor out a positive 3, what does that leave me with? Well, it leaves me with a negative x plus 7. Okay, now looking at these two, obviously they are different. In order to proceed, they must be the same. And they always will be if you might have to factor out a negative component. So that's what we have to do here. So instead of factoring out a positive 3, we're going to factor out a negative 3. I'm going to factor out a negative 3. I've got an x minus 7. That's exactly what I want. Now I can proceed. And I'm done. Okay. And there's avoiding mistakes. Be sure to bring down the greatest common factor in each successive step. That's what we do with our 5x. Let's see. Nothing different there. I'll just go ahead and snip this example 5 because again it's a prime. Did I snip the last prime one? I forget. New page. Just looking at this, we've got factors of 6. Add or subtract them together cannot give me 8. Or sorry, negative 8. And so similar to previous slides or previous section, we do have primes. And that would do it. So let's do example 6. Okay, so excuse me. We're going to use the AC method for a particular problem like this. Now, obviously, it's not a second degree polynomial, right? It is a fourth degree polynomial, but it's kind of in the form of an x squared. Okay, and I'll show you what that means here in a second. So if I were to I don't know if I said it might be confusing, but I'll go ahead and do it. Okay, so if I were to write 2x squared, actually let's not doing x. Let's do y, just as to not confuse. Okay. No, I'm not going to do that. I'm sorry. Hopefully you're not writing this stuff down. I'm not going to touch on that now. We will come back to problems like this in the future when we do substitution. But for now, it might just be easier if I didn't do that. So let's go ahead and proceed here. So using the AC method, looking at my A and my C, we've got A times C is equal to 2 times 2 times 2, which is equal to 4. Well, this seems pretty easy, doesn't it? All right, so I'm going to ask myself, what are my factors of 4? Well, that's easy. We got 1 times 4 and 2 times 2. Okay, well, which ones, when I add or subtract them together, will give me a positive 5? Well, that's obviously going to be a positive 4 and a positive 1. So let's rewrite this. We've got a 2x to the 4th, and if I put a star by it, kind of stay consistent there, 2x to the 4th plus 4x squared plus x squared plus 2. Okay, and this actually brings a pretty good point here. So how did I know to put the x squared there? Okay, well, that's because I'm looking at the variable in my b term, and I just follow along. Okay, because again, I'm adding these together. If I were to go back and look at previous examples, which I will here in a second, I said before that this equation and this equation are pretty much identical, right? Except for the fact that instead of writing a 5, I wrote a 4 plus 1, which is perfectly okay, right? I'm 33 years old, but I can also say I'm 26 plus 7 years old, okay? So I don't guess I have to go back, but I will. Look in here. Notice we have the x variable, and then when I substitute it in, I also use the x variable. All right, x to the first power. And I'm pretty sure that's all we did so far. This example is just a little meaty. So we've got the 2x to the 4th plus 4x squared plus x squared plus 2. Next thing I'm going to do is I'm going to factor by grouping. Okay. What can I factor out of the left side? Well, this looks like I can factor out a 2x squared. And what does it leave me with? It leaves me with an x squared plus 2. And then I can factor out a positive 1 on the right side. That leaves me with x squared plus 2. And therefore we've got x squared plus 2 and 2x squared plus 1. Okay. And I believe that was the last example. All right, so we're at the end of lecture. Does anybody have any questions? Oh, somebody did have questions. I'm sorry, my screen didn't flash. Oh, that's a private message. Okay, so somebody sent a private message to the sample student. Again, the whole point of bringing up the sample student is because I have 2 screens and I'm looking at my tablet nonstop. And I'm going to go ahead and end this lecture here.